Hi, Year 11th, this is Mr. Lim here again, and this is our first video on materials and separation techniques, pure substances and mixtures. So let's get started. Right, we're going to be learning about these things here, pure substances, elements, compounds, blah, blah, blah. You can read that later. Right, so pure substances and mixtures. Pure substances are substances that are made up of only one type of particle. Okay, so one type of particle. Particles can either be elements or compounds. All right, so what are elements? Elements are substances that are made up of atoms that all have the same number of protons. Okay, so effectively, every single atom present has the same number of protons, and therefore that is an element. All right, if you're talking about a compound instead, they are substances that are made up of atoms that are chemically combined in fixed ratios. So they don't have to be, or they're not made out of the same element, right? But they are chemically combined and therefore in fixed ratios. What does that mean? Does that mean if you have a water particle, so that's H2O, so there's two H's and an O there, right? If you have only water particles, you have a pure substance, but it's a compound because they are chemically combined, covalently bonded, and they're in fixed ratios, 2 hydrogens to 1 oxygen, right? So you have lots of these particles, then it's a pure substance, even though it's made up of more than one type of atom. It's made up of all the same types of particles. Okay, so that's why it's one type of particle, right? Let's move on. Mixtures then are substances that are made up of 2 or more types of particles. 2 or more types of particles, not like necessarily atoms, right? There are 2 types of mixtures depending on the distribution of those particles. So it's the distribution, homogeneous and heterogeneous. Okay, so homogeneous, where all the types of particles are evenly spread out. Okay, so effectively they're nice and spread out. If you take a portion of it, or take 2 portions from different places, they'll have identical proportions of component particles and thus properties as well. Okay, and so in general, aqueous solutions, or things that are dissolved in water, are homogeneous mixtures. All right, so if they're evenly spread out, if you take one from the left part and one from the right part, take a bit out of each, they'll be exactly the same because all the particles are evenly spread out. Right, the other type is heterogeneous, where you've got the types of particles are unevenly spread out, right, which means that if you take 2 portions from different places, you can have 2 portions with different stuff in it, right, different stuff in it because it's unevenly spread apart. Okay, here's a bunch of examples of things. Let's see if we can identify what each of these things are. I'll give you a second. That was more than a second. Let's go through what all of these are. Okay, so if you want to work out what all of these things are by yourself, then you should probably do that before I start. Like, do it now. Or now. You should press pause. You should press pause and do this. Okay, I'm doing it now. All right, this one here is a compound. This one here is a mixture, right, because they're not chemically combined, right? This is a mixture, right? This one's on the left is a bit hard to say whether it's a homogeneous mixture or heterogeneous mixture, right? This one here, mixture, different types of particles. This one here, elements, because they're all made up of one type of atom. Compound, element. Notice how those are covalently bonded to each other or bonded to each other. It doesn't matter. They're still made up of the same atom. Therefore, they're elements. Mixture, 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 compound. That's a mixture because if you look, that one's different to that one, right? It's a mixture. That one's also a mixture. That one's also a mixture. That one's also a mixture. All right. So that's that side. This one is an element, compound. This is a homogeneous mixture. And this one is the heterogeneous mixture. Okay, because if you take this portion here or that portion there, you're going to get different compositions of stuff, right? Whereas if you take these ones here, you're roughly going to get the same thing every single time. Okay. Generally, very small samples of substances are homogeneous mixtures, so small samples, whereas the large substances are heterogeneous. So a sample of air versus the air around the Earth, those are homogeneous or heterogeneous because of the size. Same with seawater, samples of seawater or all of the seawater. All right. If you do have a mixture, the properties of the substances will change depending on the proportion of component particles within that system. Right. So if you think about like your cordial and water, if you have lots of cordial to a little bit of water compared to a little bit of cordial to with a lot of water, those proportions of component particles will change the properties. Okay, so pure substances will have well-defined properties, so that's pure substances, like pure water will boil at exactly 100 degrees, but mixtures will have properties that span a range of values. So if you see something have a melting boiling point, which is a range of something, then you know it's a mixture of some sort. Right, so salt water will have around about 100 degrees, but not exactly. Right, and then the proportion of those components can have an effect on the properties. Okay, so don't know if you've ever seen someone biting a gold metal. Just to check that is 100% pure gold. That's because you can bite and dent your gold medal if you ever want to win one. If it's 100% pure, but if you have like any gold jewelry, like 9 karat gold, 18 karat gold, that kind of stuff, it's the added impurities make it a lot more rigid. So the amount of stuff that you put in there makes it more rigid. So 9 karat gold is much more rigid and much more tougher than 18 karat gold, and then 18 karat gold is much more tougher, rigider than 24 karat gold. All right, so that's it. That is pure substances and mixtures. Adios.